So we're Radiator Labs. We're developing an energy efficiency retrofit for steam heat. Basically what we're trying to address is the overheating issues of steam heat, which is used to heat a lot of buildings in older cities, a lot of buildings that were built before World War II. The only technology available was steam heat. The way we're addressing the problem is by building an insulating enclosure that goes over every radiator. This insulating enclosure blocks convective heat flow, it blocks radiative heat transfer, and we reestablish heat transfer to rooms from those radiators via a thermostatically controlled fan. So when the room is under set point, the fan turns on, it blows heat through the enclosure, out into the room, and the room hits set point, the fan turns off. The key thing to realize in the system is that when the fan turns off and the steam system is still operating, the enclosure heats up to 100 degrees Celsius very fast. When it hits 100 degrees Celsius in steam, that's the phase change temperature between steam and water. And when it hits 100 degrees Celsius, steam that enters that radiator is no longer thermodynamically driven to condense. And so the end result is that the energy that would have otherwise overheated that room remains the steam in the steam system to be drawn to another apartment. So when you install this in a single apartment, you solve the overheating issue that anyone who's lived in New York City is well acquainted with. And when you install the system building-wide, you actually redistribute energy delivery, and you actually can reclaim up to 30% of the energy costs that NYSERDA, for instance, estimates is the waste intrinsic to steam heat.